Okay, so number 11 says, be able to interpret a phase change diagram with pressure compared to temperature. Now, the one on the left is just like the one that was on your worksheet. It's for CO2. The one on the right is for carbon. And carbon, the green and the white really are both solid forms of carbon. But one is graphite, the cheap stuff that you use for pencil lead, and the other one is diamond. Okay, those are the two forms of carbon. And actually, you could put coal in there, would be another form. They didn't distinguish between them. But so if you look at that graph, what's the difference between whether you get graphite or diamond? Which condition does it depend on? Temperature or pressure? Pressure. Most of you probably already knew that, but this graph clearly shows that the difference between getting a diamond or a piece of lead is how much pressure you have. What's normal pressure? Normal pressure is 1 atmosphere, or 10 to the 0. Okay, so this starts at like 10 to the 0. I guess this is 1 atmosphere here, and then you have to have quite a bit of pressure to get the diamond, which is why most people aren't making diamonds in their basement. But the other thing you should realize about this phase change is that where you see a line between two phases, where you see the line between solid and liquid, that's where the melting and freezing is going on. So how do you know if it's melting or freezing? Well, if you're increasing temperature, you're melting. If you're decreasing temperature, you're freezing. How about pressure? If you're increasing pressure, usually that means you're freezing. You're pushing it closer. And if you decrease the pressure, you're allowing it to expand. So that's what you should be able to predict. Where all three lines meet, that's just called the triple point. 3 lines together. You know, where lines cross, that's a point. It just means you've got all 3 phases there. So if you saw that for water, it'd look kind of weird because you would have bubbles in ice water, you know, slushy ice water. It kind of looked like Sprite and ice, I guess. I mean, not so weird, I guess. And then the critical point is the other one. And the critical point is kind of weird. It's usually at the far right edge of the graph, if I can get untangled. So over here, here's the critical point for CO2. What that means is your gas has gotten so hot that no matter how much pressure you put on it, you're not going to get the particles close enough to be a liquid. You're only going to get back to the liquid phase if you decrease the temperature. Okay. But that's really about it for that phase change graph. It just shows you what you already knew. If you increase temperature, you increase motion, and you tend to go from solid to liquid to gas. If you increase pressure, you have the opposite effect.